So we have 1 hour discussion panel on prepare your phone because we will get your opinion about stuff. And we have one first virtual and panelist and Mulder from Wageningen University, research professor, uh, soil landscape group. And so let's from the soil benchmark projects. So we will discuss a bit about what's the state of technology, especially earth observation technology, soil spectroscopy, air technology, for monitoring soils. And yeah, so I will do just a bit to introduce a bit the topic. What's happening, at least what I know what's happening in the field of technology. And then we will do the slide, and then we'll get to panelists, and you can also ask questions. And please vote for the questions because we will only ask about 5 questions that you put the most vote. So anybody can ask. You can have 100 questions, but you'll ask about 5, maybe a bit more depending on time. This is the all the technology now rapidly evolving, going from Earth observation to we have a new of this government and satellite. You're building this data to providing bigger and bigger data available. Yeah, but so if you have a company, US yardstick, they made this drill machine that you tap in the soil and pilot should be able to get in real time, the test and solve properties. So there's a lot of things happening. And we have the European Space Agency. It allows for this new satellite, a couple of coming up now, especially take a look at China, LSTM, monitoring there's a 4 or 5 thermal bands, and China with the hyperspectral. They do mention soil properties here, especially from China. So hyperspectral, I can see some plans making. So a real revolution. It's not going to be open data, so we all need. Then for Europe, you see the data sets popping up. I just put 2. I mean, again, biased. The one on the right is easy, but one on the left is the German Space Agency made called Sol 3. And been recently released. It's a very surface soil vector, 20-meter holder. And we made a Lancet even back in time, which was year 2000. And so there's a lot of data sets. This is, we're here now, and this is the big hotel. And if you go to Esri way back, you can access 20, 30 centimeter images of the world, anywhere in the world. You can see changes, and you can digitize content. Data is not broken, but you can Esri allows you to digitize content. You can see how the things disappear. So anywhere in the world. So it's a nice platform to communicate things, As I said, it's not open data, but it is a website with the URL that you can share and changes. And Planet also very ambitious, where we have Planet with us in the project and also here helping with the events. I saw a presentation they would like to have soon daily revisit. So every point in the world, a daily revisit. So events that what happened yesterday, it's possible. And going for a resolution up to 0.5 meter. At the moment, I think 3.5 meter. Lots of things. Then you can also order Earth observation data for really if you want on farm scale. So you need a very detailed data. The prices, I mean, we go $2 per square kilometer, up to 23 for cash tasking. Then we have this Ultra has a 20 centimeter radar images. I saw some examples there, like mind blowing. So it's super high resolution, penetrates clouds, so they don't depend on the weather. The price of the pricier, but also it's ready to go to what you can do. And then we have this Pixel now has a hyperspectral images, 250 spectral bands, 5 meter pressure resolution, also looking already order data. New thing also, this startup in UK, they made a cloud, cloud blind days. It's like a big Zeppelin, and they really they said they very it's highly cost. They make this point wider cloud. We have a both optical imaging and a point cloud wider everything. This one is well, there's a video, but I'll skip it. It's called a chat to geo. You can use kind of like a chat GPT type system to basically talk with data, especially that output with plots or maps. But there's also some talks, and I pick up this is recently podcast with Professor Hengl, who's a retired professor who's talking with, and he actually thinks it's a bit overhyped. It's regenerative agriculture and organic farming, and so there's a bit of a hype also. And I think soil health is also a bit of word which is still quite very very general, very vague, and so there's still lots of discussion whether that's correct in then source spectroscopy. We got this new spectral scanner. I know I was in Nairobi in 2011 visiting in person, and at that time they built a whole lab just based on source spectroscopy. They had only a small section on optical analysis, and the rest was all source spectroscopy. There was a discussion that in few years everybody will source spectroscopy. That was 2011. It was just take over. And now we ordered this spectra company Netherlands represents the company in Egypt. You pay $2,500 to buy these. It's not very expensive. It has a nice range of spectra, but about $2,500. Normally it takes, but you have to pay the license, the software. And if you use it for non-academic purposes, that's on the application and YouTube, you have to pay $2,000 to $8,000 a year. So it's quite an investment. So anyway, that's a lot of things to discuss. And but let's go to the slide. I think that's the so. Are they going to be able to find it? So we have to move. We have to move. Okay. See if it works. Not like that. Maybe. Yes, working. So let's go to the slide. And now you have to get the slide on the big screen. Assuming that you slide on its only few. We have 87 volts for the Okay, let's go to the next question. Which flow depth are you interested in? We should like to see this is from what comes out. What do you consider your domain affected domains? We can eventually. So you can go to multiple. I mean, it's good to because some of what we multiple people never integrate. Okay, let's go to the next one. If you use spread observation data already, do you use more open field data or commercial usage? Which one do you use more? If it's more commercial, it's on the so one is commercial and five is open, and three is in between. If you use both commercial and open, so it's maybe an open. So which of these commercial Earth observation products you use for the work? We saw the presentation today. For your work can also be for research now, research is also one. At least I believe. Let's look at the next one. How frequently are you using AI technology for work? Let's be honest. Number five, it means you use it for most of the work. You try to solve everything with AI, code, articles, abstracts, emails, summaries. What is your main domain application when using, for example, domain application when using AI technology for work? One more time, I will share all these results. Tomorrow I will summarize, I will show you the full day summarize, and then we will share the results with you. Start with you for next question, please. In which year do you think AI technology will reach all 99% of 9 million farmers in the whole EU? So every farmer in EU using AI technology almost daily. If you know farmers, I don't know, farmers ecology and their capacity depends on the country, of course. Yeah. Let's say EU. The next one. What is, in your opinion, the most important application use of soil spectroscopy? You can put the three words here. What is the most important application of soil spectroscopy? So that is a three-word cloud. Some things are a bit higher rated. So, well, we can go to the next one. Why is, in your opinion, soil spectroscopy not yet used by majority of farmers, landowners, land managers? Why is it not used? You can also put multiple. We have a company here in that serving soil spectroscopy products. Or well, we all do it in our projects and also at JRC, right? Look at soil. It's all the samples are analyzed in European, so in standard lab and scanned, but only NIR, no, not the MIR. Yes, yes, okay, yes. So it is widely used. You can go to the next one. What is, in your opinion, the most promising application of AI technology in soil health research? Or general health, AI technology, LLMs, machine learning on big regulating data. What is the most promising application? You see somebody has a good word that you can just vote on that word, I think. Mhm. How could Earth observation, soil spectroscopy, and AI technology change best be used to improve soil health? So how can it use technology best be used to improve soil health? you need to think a bit. The idea is to think as an investor. So what you think it really work? Take home, have users, have customers. Let's go to the last one. I think it's the last. So you have this podcast. You can listen to it, but in general, Professor Hengl warned of the dangers of populist narratives which oversimplify agricultural challenges. How many projects today they call themselves regenerative do you believe are genuine or really regenerative? Basically, the question: do you think it's a big hype and populism, or is it really dominantly correct? Oh, that's very interesting. Uh, We have them all. Okay. So thank you so much. This is the feedback from you. You can still ask a question. Keep 13 questions. So please, if you have a question, also vote for questions, and we will put up the top five, I think. So if you have a question, post it, and also please vote. Without you voting, we don't know which one is going to. So let's go to something from so based on the panelists we have here. Let's go to the soil spectroscopy. Why is, in your opinion, soil spectroscopy not yet used by majority of farmers, land managers? Can you go back to that, please? Yeah, so we'll open the questions and we'll dig into that. Why is, in your opinion, trust not get used by majority of farmers when usually? Yes. So we got too complex to use. Let's see our panel if we have to the microphone. Okay. So let's start with Titia. What do you think about this result? We got the too complex to use, number one. Number two is the required calibration is not required. You did a PhD in social purpose, you know?
Yeah, I did nearly 20 years ago. So yeah, it's been a while. Yeah, so why is it complex to use? Well, if I actually we did put in that answer ourselves. So I tend to agree with the answer. And so I think when you look back at the farmers themselves, I think there are only a few that are very tech savvy. So then for them, if you provide these tools, and well, they have to make a planning and an adjustment and actually plan activities in the field to collect the data, make sure that it's accurate data, that there's not too much noise in it. And then, well, after they collect it, they need to, well, somehow translate it into soil properties or, I don't know, fertilizer recommendations for something about their crops. That's quite difficult. And so if you're not a specialist in, well, any of the disciplines that go along with it, I think it is quite difficult for them to use. So if it, they are their own specialists in growing the crops, working their fields, optimizing their management practices. They kind of lack this training. So it's quite overwhelming, I think, if you just ask them to adopt this technology by themselves.
And there was when you had the soil health benchmark plan project over there in the Omnia, and there was remember a young lady from a farmer association, and she said that the farmers really put off if you tell them I'm going to come to your land, I'm going to sample, and I'll give you the results, for example, in 1 month or 2 months, you get the result. And they're kind of like, I would like to have results tomorrow. That puts them off this delay in the complexity, right?
Yeah, so I think that had to do with the delay just with the lab analysis. So the sampling, they are very keen to get the samples done, but then they start to plan their land management, so they start to till and they start to prepare the soil, and then sometimes the recommendations come in too late. So I think there was the delay for the farmers organization saw really a problem. Also the complexity of the lab analysis that they got back. They were quite difficult to just already work with.
And what's the now, like if you say now state of the art 2025, like Wageningen University, how long can you, how fast can you do lab analysis? Give really solid data and back to people. From the field sampling to result.
Well, I do not work in the lab, so I really do not dare to answer that question.
Paolo, do you have some estimate what the turnaround from taking a full sample on the field and having like estimated, how much so far in the lab? So how much time it will take to say like realistically? Right. I can not that because it looks up, but I don't need the you that not to get stop. Because you do research, it's not gonna you don't be very fast, right?
Yeah.
The project and the program benchmark, is there an idea to have it like more likely to almost all the field that they have some data, so data based on sampling.
Not we do have an idea. So the idea in terms of speed and time, yes, we are going to assess that, and also this is the next task actually we discussed last week during the AGM, to provide an average of price, how much it can cost on average at European level, let's say, because each country has a different rates. And the time that takes from the sampling to the lab processes, and this can give an estimation. And I think indeed we should include the results output. So the idea is to at least give an indication, because time is money, and if you are a farmer, you want to know also how long does it take to get your results, and how much after you can plan your activities according to the results you get. Yeah, this we are planning to give this indication as part of this soil health indicator framework. That is.
We move further because we have we move to Madlene. Let's go to this. What is your main machine? That's your choice. I think people wanted research and writing report. So that comes up. And then not to wait to use that technology or fully supported. But what if now add technology, and for example, this automated machine learning, you just throw the data and you get the model feeding out. Does it mean we don't have to learn statistics anymore, or it can work defined?
The current state of things is that I still have to take many decisions, and the system is not. That's why I also usually don't call it artificial intelligence if I process data, because there are many decisions I have to take how to process it exactly and which method I choose at which step. And this is by far not an automatic process. And I could maybe now have a discussion with ChatGPT about it. but still I'm not confident that AI system will completely automatically be able to decide it and still be able to produce a fully meaningful result.
What about in 10 years?
What about in 10 years?
Soil data is in the whole universe of AI application, soil data is an absolute niche. So I don't expect it will be possible in 10 years.
Okay.
So, and statistical knowledge and so on is still necessary.
Let's see
and
if Pete Smith is with us online. Pete, are you with us?
Yes, I can hear you, Tom. Yeah,
Yeah. You can see the results, I hope.
yeah, I can. Yeah,
Do
I
they
contributed to
surprise
it.
you, this how people use AI technology mainly for their work?
No, it doesn't surprise me. I've seen a real increase in my group, you know, in people that work with us, especially if they're not first English language speakers. They're using it to
Can you speak a
improve.
bit closer to the microphone because we have a
Yeah,
problem?
sure. Using it to improve the language of the reports. So whereas I used to do a lot of copy editing, language editing of reports and draft papers, I'm now getting much better written because they're using AI to improve the language. So it's not replacing the scientific input, but it is just getting rid of some of those boring tasks of language editing and making it better. I've also seen it used to, and I've used it myself, to summarize long documents, to just get a summary out. You know, if you've got to write a 300-word abstract, a good way to do that is to use AI tools to summarize it in 300 words. Then you can go back and edit it. So I find it a very useful tool.
Do you use daily? Do you use daily like some AI chat?
Me? No, I would
tool?
use it. I would use it maybe every week or every couple of weeks. And people are
Okay.
also using it to write bits of Python code in my group as well. I don't use it. I don't do any coding anymore because I'm too old and out of the picture. The people who still do the coding use it to generate code, which they then edit and you know, get into the right shape. But it's a good way to make a start and to accelerate your job.
Just going back to Madlene, do you think in the future do we need to learn more statistics or less?
Statistics, I think we need to learn more because we have to understand what AI is doing. AI will do statistics for us, but the more black box it is, then the less we are able to interrogate and to understand the outputs of the AI that we use. So I think we still need to understand and learn statistics to understand what is being given to us in the outputs from the AI.
But the issue is that it's like a bit counterintuitive because AI is going to make the work easier, so we can automate a lot of work. But in practice, we have to actually become better in our professions. We have to actually study more, and you know, the more complex data, the more complex problems, the more background knowledge we have. So it's a bit counterintuitive, right? The work becomes easier, but we actually have to study more.
I think
What
that's
do you
true.
think? We'll pass it to Madlene now. Thank you, Pete.
Yeah, thank you.
Just on the previous question, I fully agree with Pete. And I don't think it's counterintuitive. The application of all these tools has become much easier. So we have to spend much less time in actually implementing machine learning and statistics. But at the same time, we still need to know what we do and have a clear picture of to put the outcome into perspective and to actually be able to have a proper interpretation of the outcome and the results. And without a sufficient background knowledge, we will not be able to put it into perspective.
Yeah, in your example, you show this smoothing effect of machine learning, how it can actually basically put off people that know areas. They said, no, I know this area, you don't have it. You're missing totally this low pH or some clay content. So people actually can lose trust, you know, if you automate and ignore things. So it can actually send the technology a bit back, right?
Yeah, they feel it's it might be useful, but not for my case, because it's
Mm.
not representing, also in the irrigation case, not representing the very sandy and the very clay soils, exactly the locations where they see the most differences in irrigation.
Okay, let's go and move to Niels. There was this question about when the farmers are going to use, all of the farmers, 99%, not 100%, but let's say 99%, will use AI technology. And most of people believe within 5 years. Do you think it's realistic? So you could reach all farmers in EU.
I think it's quite a big challenge to reach them all in 5 years. I'm also not sure if that should be our main goal, to reach them all with AI technology. I think what's important is that we provide them tools to help them monitoring and to help them implementing sustainable soil management practices. And this can be AI tools. It can also be more traditional tools, as long as we help them and support them in implementing these practices.
Yeah. The other thing is, I mean, when we say technology, most of the technology, at least that you use now in WhatsApp, as you notice, it popped up. Meta has AI also integrated in WhatsApp, and Google has a Gemini integrated now in Gmail and all this stuff. Most of this AI is actually out of European continent, right? Does this worry you at the European Commission, maybe?
Yes, it's indeed an issue to think about it. Also to think about ethical questions that pop up when using AI or when using remote sensing or Earth observation, and to think about technological inequalities is also important to think about. Who have access to all these high technology data, who can use it, who cannot use it, who can afford it, who cannot afford it. I think we really need to think about also these ethical questions, and also about who is providing the data, who is owning the data. These are indeed things that we need to think about, and where also this research community needs to come up with some solutions and some input.
Mm-hmm. If you have questions for Niels, also please post them in the Slido, and then we will see which ones get voted, so we can ask. The JRC, do you have a special group for AI, maybe AI technology? Or there is a computing center at JRC. I always forget the abbreviations. It's a quite complex.
Yeah.
GOPD something.
Yes, we indeed have a platform with AI technology, and we also have our own ChatGTP, so to say, the European Commission ChatGTP, so that it's owned by the Commission, and so that documents that are uploaded there or that data that is processed there is all hosted by the Commission, and it's not shared with America or China or whatsoever. So we have at the Commission our own platform to do that. But it's, of course, it requires resources, it requires manpower to create this type of technologies, and that's, of course, an issue of finances as well.
Okay. Let's go to the last keynote about this populism. About the populism, the last one, the Ken Giller, yes, interview podcast. So we think. You maybe not familiar with Professor Ken Giller, but it was a podcast, and he was a bit critical about this hype a bit on conservative agriculture, organic farming, and then when you look at the differences, between somebody who doesn't know what they're doing, then the difference that's huge. And what is your experience? Is it this populism in about how we produce food and how we treat the land and things? Is there a danger in that? From a business also point of view.
Yeah, I think. Do you hear me? No.
You need both.
Yeah,
You need both mix.
Hello. I think this one. But this as well. Okay. I guess actually that business and finance can help because they don't care what's written on the doorbell, whether it says regenerative, organic, biodynamic, whatever, ecological, intensified. They just want to see whether it works. I mean, in my previous job, I was basically traveling nonstop, and I was like to all parts of the world, and I was typically positive surprised to see what's happening on the ground. And some of them who never heard of regenerative were like the most regenerative ones, right? And then there were also clearly some hobby farmers calling themselves organic or even biodynamic, but just doing the minimum. So it's hard to judge. I think, let's say the scarcity of functioning nature forces people and farmers to do better practices, because returning biomass left, right, or center to the soil somehow increases the resilience of the system. And whether it's called regenerative or not, I don't care too much as long as it delivers. But yes, on the other hand, if you look to all these fancy programs on those shiny websites where people make all these pledges and say, we commit to 12 million hectares of regenerative, whatever. I mean, they don't even know where the stuff comes from. So how can they do this?
Do you have any special strategy against greenwashing? Like companies just, spending a very little amount of money to produce some publicity, some positive publicity?
Well, I don't care, to be honest, too much about greenwashing, because I think if they greenwash, they don't benefit from it. I mean, maybe in the market, but generally, if they say we save water, but they don't, then they still pay the higher bill. So that's, I think, also when people ask me this question in other contexts, I say let's focus on the good stuff and not waste time on the ones which.
But your Landler is a data driven, so you have
outcome based. If it works,
so you can validate. I mean,
yeah.
If somebody claims, it's just not just a number. There is also a detailed data set behind.
There is a detailed data set behind, but as mentioned, as our benchmark is the acceptance in the financial market, now talking about land banking group and Landler, it's only a fraction of it. I mean, we look at some water aspects, some biodiversity or land use aspects, and some carbon aspects. So it's just a snapshot, but at least it's more holistic than just looking at soil carbon. Also, because there you clearly see some trade-offs, negative ones.
Okay, we have now questions from the audience. We have still some time, and I see you voted. We can go for the top voted questions. Let's go from really start from the top. So if I see the correctly, there's a question. What is the balance between scientific accuracy in data and practical usage? What is the balance between scientific accuracy in data and practical usage? Somebody wants to try? Yes, Tobias?
We can start with the one far end. What I said earlier, that the financial market is now asking for data, is true. But where they come from is that the whole financial sector uses a static database called Anchor, which just says, you are in cement industry, this is why you have a water risk. That's it. And based on this, interest rates are defined. So anything on top is great for them. Yeah? And then comes the scientists and say, yeah, but it could be 3.7 instead of 3.75. And they say, so that's, let's say, in business, still a big bridge to build, where I think also as a scientific and data community, we need to bring some rigor, because wrong decisions are made, just for pragmatic reasons. But if the first step is too big, we're also gonna scare them off. So solution, well, work in progress, but this is the reality.
Let's see, Titia also, please. Yes, just the microphone we pass on. The double microphone. One for the here, one for the virtual, yes.
Okay, yeah, so I'm looking now at the question scientific accuracy in data. So I do not want to talk then about statistical accuracy. But I would like to raise the question actually is, well, scientific accuracy can also be that you are making sure you're actually using the right indicator to answer the right question. And to also know that you can rely then on that indicator measurement. So I would put that back to you. So where often, well, we say, well, we're gonna use organic carbon to monitor soil health everywhere. Of course, it's accessible, but it is also now quite well known that it's quite context specific, and depending on the objectives, maybe yeah, it is good to also then have the discussion about what indicator we should actually use to measure and report on. And I do see that there is still a role when it comes to scientific accuracy in data. And then I'm not even touching upon yet the statistical accuracy, but maybe you would like to do that.
Well, let's also make it clear that sometimes, you know, we obsess with some accuracy, right? We want to super high accuracy, but actually to improve the land management or some decision, you don't need such a high accuracy, you know. Like you also spoke about this, the balance, you know, the how to choose, and so maybe sometimes it's better to have a quick data, maybe not so accurate, but it, you know, produces usage, and it's like what we heard, it works on the ground. So why obsess with the accuracy? So please.
Well, why obsess with? I mean, we are driven by achieving the best possible product if we do research for these type of methods, of course. But then, and at the same time, we try to do this in a very general purpose manner so that we can accommodate as many users as possible. But if we look at the user side that do, for example, policy implementation at a local government, they sometimes just have a binary decision. It is inside the class or outside. And therefore, maybe we would need to adapt our data products more targeting their exact decision, and also then optimizing the accuracy for their exact decision and achieving then most accurate accuracy level, so they do not so the risk of taking a wrong decision is as small as possible. So it really depends on the resolution of the final decision. And of course, if we go for the three digits after the comma for texture, it's useless.
Yes,
the end users will not be interested in that, but also our uncertainties we have in the model and even in the lab measurements are anyway much larger than that. So we have also to put it into the perspective what we are capable of doing, and providing more adapted end users products that are very specific to the decision that is going to be taken.
Okay. The other question we are looking, are there any open access EO-based soil health indicators that can currently be used at plot level for a farmer? So so plot level, I mean, it's like just one farm, one polygon or something. So yeah, well, I mentioned the soil suite. I mean, 20-meter resolution. You could say it matches it fits the scale, and we are building the soil health data cube. We're doing workshops in the afternoons, so you can get your hands on the soil health data cube. It's open, so you can use it, you can download it, you can crop it. And so we will show you that. So there are two, at least that I know. And soil health benchmark also, you're producing also pan-European data, Titia, in the soil health benchmarks, producing some pan-European data that can be maybe used as open data.
Yes, it is part of our deliverables, and so we are working on it. And then yeah, especially with a focus on the benchmarking and yeah, developing useful indicators. Yeah.
And do you spend a lot of effort in the processing Earth observation data? I guess you're more, I think when we spoke on some meeting, we said you are more like a location focused project. So you're more focused on the ground in situ, and we are more focused pan-European. What Moens also said in the morning, we are more like a whole Europe pan-European. Is that true?
Well, I think what is the major difference between us is that you go top down and we go bottom up. So far we started really local, and so next year we are scaling up to the landscape level. But we do have the support of research institutes that help us process all the Earth observation data, and also with the predictive mapping.
Okay.
So it's there, but yeah, we're now 2 years in. We still got 3 years to go. And initially, indeed, we started at the bottom, and now we're moving slowly up.
Okay.
Yeah.
Maybe somebody here wants to answer that, the useful EO data. So, well, there is new products from European Space Agency. Okay, Nils, you don't know about them, but do you have any also plans to create something high resolution, like between 10 and 30 meters within the EU Soul Observatory? Are you planning to produce some EU-based products?
That's not part of our work program so far. We will
Okay.
not produce this high resolution data set. Also because our main data sources like Lucas data sets does not allow us to work on the resolution of
That's fine,
10
because
meters.
there's a, European Commission has different groups, and so I know the Copernicus land monitoring services, they do produce products, and many of us use them, and they have these very high resolution products also. And David just sent me, I think a couple of weeks ago, there was this product to estimate the ceiling intensity, I think, generated from Sentinel-2. So there's quite some products coming up from different groups and different European projects. So I think the Earth observation wise, we are rich. Earth observation wise, point wise, in situ wise, for soil biology data for Pan-EU, there is only Lucas that we can use, and only 600 points. That's it. The soil biology in Europe is 600 points that you can use. It's incredible. And and now in the 2022, maybe more data.
A bit more, but at the same
At the same scale, yes. But imagine that. So the difference, we have terabytes of Earth observation data, and then we come to something like soil biology, and somebody says, I would like to test something, and you have 600 points. That's it. Yes, we are slowly finishing. 4 more minutes before lunch.
Or maybe if I can add, of course, JRC is working on trying to integrate these different data streams and try to integrate these Earth observation products that are coming up with traditional soil monitoring work.
Mhm.
That is, of course, a challenging task, but we are working on it also in cooperation with the other teams from Copernicus, etc.
Okay. Yes.
Maybe just a quick one on this. We are here in a scientific conference, not political, but I mean, we currently get twice a week a radar measurement to measure soil moisture from both ESA and NASA. But the NASA part is also co-administrated by NOAA, the National Oceanic and Atmospheric Association, which is now gradually being shut down by friend Elon. So we already see that for some periods accuracy goes down there. So it is super important that we have high resolution data on all sorts of different things in Europe.
Yeah. One more question pop up and then we'll stop. It's for Nils. So we have a couple of projects now where, for example, in meteorology, we have these climatic stations and we have FluxNet stations measuring gas fluxes and primary productivity, etc. So these are really stations, they are stations and people maintain them and they stream the data non-stop. And what about soil stations, to have a permanent soil stations that measure? Now we have an international soil monitoring network. They measure every minute soil moisture, soil temperature. But what about something that we, permanent stations that, so like Lucas is revisiting sites, but something not that you have to wait 5 years, but you have almost like every week or something, measurements. Not maybe soil organic carbon and okay, that soil texture wouldn't change in 10 years. But to measure, I don't know, some chemical soil properties and soil biological indicators. What about that? Is that a fantasy or is this somewhere in the Brussels discussed maybe?
I don't think that specific topic is being discussed in Brussels at this moment, but indeed it would be great to have this type of things and to learn from other disciplines how they did so. And the challenge there will be, again, how to integrate it with other data streams and how to come from these monitoring stations to EU-wide data sets. That will be quite a big challenge, and to integrate it with other data streams. But we're open to work on that and then to take the challenge and take it also on board.
Okay, thank you. I hope the questions were not too scary. And thank you all for voting and for voting also on the questions and putting questions.